The last example with inequalities is when we deal with incorporating undefined points. And so a point of x equals a is undefined for a function f of x if when I plug in a, if f of a does not exist. And this really most easily occurs in fractions, right? If I take an example of x minus 5 over x squared minus 4, right? The one thing we know with all fractions is the one thing we can't have is the denominator cannot be 0. So what we want to do is we want to find these undefined points. And the way we do that in this case is by taking our denominator and setting it equal to 0. Right? So let's look at this, right? So for what values of x does this fraction not exist? Does it have undefined points? And just like we said, I'm going to take that denominator and set that thing equal to 0. And here I just look to factor. I'll get x minus 2 and x plus 2, right? Remember, we want to look at that and see the difference of squares. And so I get x is equal to 2 or negative 2. These are going to be our undefined points. And in the context of solving inequalities, these are going to matter just like setting this thing equal to 0 will. So let's look at an example. I want to solve this inequality. X minus 5 divided by x squared minus 4 is less than or equal to 0. And we bring up this idea of undefined points because when we have a fraction, I want to consider two things. I want, when is this equal to 0? And where are my undefined points? And what we're going to do is we're going to do this sign diagram for those two categories of points. When am I equal to 0? And where are my undefined points? So the first point we want to find is where we're equal to 0, right? And to do that, all we do is set our numerator equal to 0. So I take x minus 5 and set that thing equal to 0. And I get x is equal to 5. This is one of the points we'll put down when I deal with the sign diagram. The second thing is I want to find my undefined points. So I'll take that denominator of x squared minus 4 and set that equal to 0. And again, I get x minus 2, x plus 2 is equal to 0. And I get x is equal to 2 and negative 2. These are also going to be points I want to put on my sign diagram. But before I move on to my sign diagram, one thing that's going to be important is taking this idea, that fraction, and then factoring it first. Right? And we've already done that by solving this kind of step 1 and step 2. I've actually already factored it, just like in each of those steps before. And what we want to remember is the way we solve the quadratic inequalities is by factoring this first. So that's what we're going to do. Right? So when I look at this, right, I'll put my number line down. This time I have 3 points, negative 2, 2, and 5. Right? I always want to put my undefined points down. What's different about this case is even though I have 3 points, they're not all the same types of points. This value of 2 and negative 2 are my undefined points. So if we remember when dealing with a number line, if I didn't want to include a point, I'd put an open circle around it. And if I wanted to include a point, I'd put a closed circle around it. And what that helps us do is when we write our intervals, right here it's negative infinity to negative 2, that open circle helps me remember I don't want to include that point. So when I move to a bracket, I want this open parentheses. Likewise, between negative 2 and 2, Because those values of negative 2 and 2 are my undefined points, I want open parentheses around them. When I move from 2 to 5, I don't want to include 2, but because my inequality back up here is less than or equal to 0, I actually want to include the points that are equal to 0. And in this case, I'm equal to 0 at 5, and then I want to go to 5 to infinity. Right? And I set up my sign diagram here. I'm going to need test points. Right? I'm going to want to know what the value of each of those test points are. And then I want to know, well, does that actually make me less than or equal to 0? And I have to find a test point for every one of these intervals. So I can pick anything here, negative 4, I'll pick 0, I'll pick 3, and I'll pick 7. We can pick any point in that interval from 5 to infinity. And what I'm going to do is I'm going to plug these values back into the factored form. It's just going to help me form a more cohesive answer if I do this. If I plug in negative 4 and I look at the top, I'm going to get negative 9 divided by negative 6 times negative 2. And if all I'm really looking to do is look at those answers in terms of their signs, this is going to be negative 9 over 12. Right? Is that thing less than or equal to 0? Yes, it is. So I want to include that in my answer. If I plug in 0, I'm going to get negative 5 over negative 2 times 2. And if I look at my negatives, I have 2 negatives overall, and those 2 negatives will cancel, and I'll get 5 over 4. That is a positive answer. I don't want to include that. If I look at 3, I'll get negative 2 over 1 times 5, which gives negative 2 over 5. Yes, that is less than or equal to 0, so I want to include that point. And if I plug in 7, I'll get 2 over 5 times 9, which is going to be 2 over 45. That is not negative, so I don't want to include that. So when I look for a final answer, it's the intervals that have the check marks. So my answer is going to be interval negative infinity to negative 2, union 2 to 5 with those brackets. All right, if you have any questions, just shoot me an email. I'll be glad to explain anything or do more examples. If not, I'll see you guys next time.